I can YouTube again now, so I'll upload these. I will, I promise. Also, your assignment sheet is on there too. We're going to evaluate polynomial functions, and we're going to talk about general shapes of graphs of polynomial functions. Some of this is review, some of this is new. But those are the two targets for today. 10:05. 9:35. Okay. That's what time we get out. You can't see? No? Why don't you move up here? Okay. Good plan. Okay, you already know what a degree is of a polynomial, right? You also know what a leading coefficient is. The degree of a polynomial in one variable, that means there's only one variable, like x's or y's, but not xy. That's the greatest exponent of the variable. The leading coefficient is the coefficient of the term with the highest degree. So there's a little table here that I had going for you, and I filled out the expression one. We're going to figure out what kind of polynomial it is, what degree is it, and what's its leading coefficient. So when the expression is 9, what kind of polynomial is that? Well, no, wrong button. Oh, goodness. Well, well, it would be constant, because it's the same thing every time. Like when you have the graph y equals 3, what is the y value every time? 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. That's called constant. It doesn't change. If you have an x minus 2 kind of situation, that's linear. Because when you graph it, what shape is it? A line, like with x minus 2. 3x squared plus 4x minus 5, that one's quadratic. 4x cubed minus 6, that one would be cubic. And then they have this lovely thing that's supposed to be like the general form. Don't worry about writing that down. I think it's just a bunch of confusing stuff. A sub 0, that's the coefficient. There's a number that stands for that. Then x to the n power. N is whatever number that's a non-zero integer. So then here you have n minus 1, because the powers go down. See how that's x squared? This is x to the first. So that means if n is 5, then the next term is going to be x to the fourth. And that will make the next one x to the third, and keep going. And then these a to the 0, a sub 1, and all these little guys on the bottom, they just tell you that these are the coefficients that go with this term. But in order for it to be a polynomial, what's important about something, if it's going to be a polynomial, it's going to have variables in numerators only. No variables in denominators. So what I mean by that is if you have something like 3x squared, that's a polynomial. But if you've got something like 4 over x, that's not a polynomial, because remember, you can't have variables in the denominator. So, would that be a polynomial? Because it go down to the denominator, right? Would that be a polynomial? Yes, because it goes up. So watch out, just because it's down below doesn't mean it makes it a non-polynomial. Because this one actually goes up and then it becomes a polynomial. Okay, what is the degree of this constant? 9. Well, remember what the degree is the variable on the exponent. The exponent that is existing on the variable. So when I write an x next to this, What has to go up in the exponent place? 0. So the degree of this is 0. The leading coefficient of it is 9. How about the linear one? X minus 2. What's its degree? X to the 1. The degree is 1. And what is its leading coefficient? Also 1. The number in the front is 1. How about the quadratic 3x squared plus 4x minus 5? What's its degree? What's the highest exponent that you see? 2. What's its leading coefficient? What's the coefficient in front of the highest exponent? 3. This is why I'm getting somebody to come help me with this thing. 3 and 2. How about the cubic one? What's the degree? 3. And what's its coefficient? Leading coefficient would be 4. And that completes the table part. And then let's do a couple for practice and see if you get it. If I say anything wrong, really transparent. I don't think winter break should be 2 weeks. It should be 4. It should be what? We should get off the 24th to the 1st. That's it. Okay, 2 for you to try. So you have to state the degree and the leading coefficient of the polynomial. If it's not a polynomial in one variable, explain why it wouldn't be. I'm guessing you pardon me. So for example 2, we're going to do the same thing now, but it's slightly more complicated because there are 2 parts. So first, we're going to find q of a plus 1. Which means instead of x, what are we plugging in? A plus 1. Then we're going to find 2q of a. What does that mean? Well, instead of x, what are we going to plug in? A. And then what do we do with the answer? Multiply it by 2. See how the 2's in the front of it? Yeah. But then we'll subtract them if you multiply it by positive 2, or you can multiply it by a negative 2 and then add them. So yes, you can do that. I like to think of it as multiplying by positive 2 and then subtracting the whole thing. But if you want to multiply by negative 2 and add, yay, it's pretty complicated. Same thing, right? Add it into it. Okay. So we'll do this in 2 parts. We'll call this part 1. We'll call this part 2. And then we have to combine the 2 parts together. So I suggest you do that. Split it up. So for part 1, I'm going to find q of a plus 1. See if you can do that. For part 2, I'm going to find negative 2q of a. Since Xander wanted to make it negative, we'll do that. So I'm going to give you a couple minutes so you can figure this out. And if you can combine them together already, I'll give you like bonus points. Practice with this. Let me know if you need some help. I'll come around.